So we're going to go through the Microscopy RPA, which is basically how do you use a microscope, how do you measure things, and a little bit of maths as we'll have a look at. So a microscope is used if you want to see detail that you can't see with the naked eye. For example, I can see the cells in the onion or the detail in that thread and needle. So as I say, we're going to look at a couple keywords, how you use a microscope, and then a little bit of maths, but it's not as difficult as you might be imagining it to be. So in terms of keywords, there are two you need to know. Magnification, and that's all about how much bigger an image is made by the microscope. So the larger the image is made, the higher the magnification. And resolution, and that's about your ability to tell two parts of an image apart. So it's the fineness of the detail. The higher the resolution, the more detail it has. If you think about it, you probably already know this, because let's just take a random YouTube video, no relevance. What you can do is you can change the resolution of that video. If I click on that little cog, and I can increase the resolution, and I'll have a higher quality video. And it's the same idea with a microscope image. So just because I increase the magnification of something, it doesn't necessarily make the resolution better. Here's what I mean. Let's have a look at this image of me reviewing my own voice on one of these recordings. Now I can magnify that, I can make it bigger, but that doesn't necessarily increase the resolution. So in an ideal world, you'd make something magnified, but you would also have a high resolution. One without the other is not that good. So if you need to improve your magnification, you change the objective lens. That's labelled D on that image there, on the labelled microscope. And an objective lens looks like that. You can just flick it round and that will change your magnification. If you want to increase your resolution, so the magnification is good, but maybe it's a bit blurry, then you use what's called the fine focusing wheel or the fine focusing dial, whatever you want to call it, and that is labelled right there on the side of the microscope. Now, because we're dealing with tiny things, it's no good using meters or miles. Instead, we use units like this. So a millimeter there, and then going 1,000 times smaller than that is a micrometer, and 1,000 times smaller than that is a nanometer. And just note that the micrometer has got a weird little symbol there. It's like a U kind of backwards and an M. So here's a basic rule for you. Let's just say I've made up a unit of length called a lampard, and I want to measure that football pitch. So if I'm doing that, it might take me, say, 2 lampards to measure that pitch. Lampard looks like quite a big unit. If I have a smaller unit, let's say it's called a Neville, it's not going to take me 2 of them because they're smaller. It's actually probably going to take me closer to 4. So the point is this. If you have a big unit, you don't need as many of them to measure the space. But if I have a smaller unit, I'm going to need more of them to measure that same space. So let's talk about why that's important to us with real units. So if I have a image and it's measured in millimeters, but I want to know how many micrometers it is, because micrometers is a smaller unit, it's going to take more of them. And because it's 1,000 times smaller, it's going to take 1,000 times more. So if I want to convert from millimeters to micrometers, I times by 1,000. Micrometers to nanometers, you times by 1,000. And if you want to go the other way into a bigger unit, for example, nano into micro, you divide by 1,000. Or micro into milli, you divide by 1,000. So the key rule is this: if you're going into something smaller, you're going to multiply by 1,000. If you're going into something bigger, you're going up that little table, you're going to divide it by 1,000. Now, you probably love maths, who doesn't? And you might want to know either the magnification of an image, the actual size of the image, or the size of the image itself. And normally you'll be given most of these in the question and asked to find the missing one out. So this little triangle will tell you everything you need to know. And that's easy to remember because it spells I am, like it's a sentence, you know, I am going to whatever. So if you imagine if they're above or below each other, like the I and the A or the I and the M, then there's a divide sign. And if they're next to each other, like the A and the M, then there's a multiply. So all you do is this: you find out what you're looking for. Let's say I want to know the image size, and I cover it up, and that leaves me A and the M, and because they're next to each other, I multiply them. So the image size equals the actual size times magnification. Let's say instead I want to know the actual size, I cover up the A, and I'm left with image size divided by magnification. And finally, if I want to know the magnification, I can cover up the M, and I'm left with image size divided by actual size. So they're the three equations you can get from that triangle. Just cover up the one that you're looking for. Now here's the little tricky bit. The fun keeps going, because if you're working out magnification, the image size and the actual size have to be in the same units. So the image size could be in centimeters or millimeters, and the actual size might be in micrometers. So you've got to put them in the same unit.